OPG has allocated $12.8 billion for the refurbishment of the Darlington reactors. Pressure tubes are a life-limiting component with a replacement cost of $3.4 billion. Improving fuel channel monitoring techniques will help to reduce critical path inspection times, improve knowledge of pressure tube health, and also help to ensure that OPG meets or exceeds its refurbished reactor lifetimes. Our technology may reduce operations costs by $60 million over the reactor lifetime, and also will increase confidence in inspection results. During outages, pressure tubes are inspected to check the hydrogen concentration, and hydrogen is a concern because its presence can lead to pressure tube embrittlement. Current scrape methods are accurate, but they're time-consuming and expensive, costing roughly $5 million per campaign. And scrape methods also require radioactive samples to be shipped off-site for analysis, exposing workers to radiation. With laser-induced breakdown spectroscopy, or LIBS, however, we can accurately measure the hydrogen concentration for a fraction of the cost with a higher reliability and a lower dose. LIBS is a well-developed method with many different applications, including one in operation on Mars. This method works by ablating a very small amount of material along the tube wall and observing the light emitted, which tells us about the hydrogen concentration. Less than 1% of the material required by existing scrape methods is needed, giving a much lower chance of introducing a flaw. And since this method avoids mechanical scraping, it's much more reliable and easier to control. LIBS measurements can be made remotely and take only a matter of seconds. Pressing a single button would give immediate, easy-to-understand results. This will drastically reduce the time for inspections and also eliminate the dose received by maintenance personnel. Workers would no longer be required to handle radioactive samples, helping to further enhance safety. With all of these factors considered, we expect that the cost of inspections could be reduced by at least $1 million per campaign. For prototype development over the next 16 months, resources available at McMaster will be leveraged, with the $25,000 being used to purchase optical equipment. Technical demonstrations will then be performed over the following 2 years, costing an estimated $2 million and fostering public-private partnerships. On-site implementation can then begin with OPG. The team behind this project is myself, a Master's of Applied Science student, in addition to the Industrial Safety Chair for UNINI and an expert in laser systems. This team combines the necessary knowledge in nuclear engineering and laser systems engineering needed to make the system work. Our device greatly reduces the cost, time, and dose associated with pressure tube inspections while maintaining a high degree of accuracy. This funding, coupled with a partnership with OPG, will help to push this idea forward and may prove to be a revolution in pressure tube inspection techniques. Thank you.